today we're going to work on simplifying radicals. And there's a couple of kind of weird things with this. We're going to go through several different pieces of information today. The first one is, if your problem starts as a radical, your answer needs to be written in radical form if that's still necessary. If the problem starts with rational exponents, then your answer needs to be written with rational exponents if necessary. Sometimes it is helpful when you start in radical form to switch to rational exponent form to simplify it that way, and then switch it back into radical to write your answer. For example, we know from a long time ago, if we have the square root of 2 times the square root of 3, we can combine those to give us the square root of 6. You can only multiply those radicands together if the index is the same on both of the radicals. So in this first example, number 8, we've got the square root of 16 times the fourth root of 16. Square root and fourth root are not the same. So we cannot multiply the 16s together under the same radical. Instead, because the index does not match, so I'm going to write index doesn't match. So switch to rational. The square root of 16 is 16 to the 1/2. The fourth root of 16 is 16 to the 1/4. When we switch it to rational exponents, now we can use those properties that we worked on yesterday. We're multiplying, so what do we do with those exponents? Okay, the 1/2, this is a square root. That means it's an index of 2. So 16, the square root of 16 is the same as 16 to the 1/2. The fourth root of 16 is the same as 16 to the 1/4. We're switching from rational to radical form. Now we can take those exponents and we can add them. So we have 1/2 plus 1/4. 1/2 plus 1/4 is 3/4. But if we started in radical form, we have to end in radical form. So now we need to switch back. Go back to radical form. The fourth root of 16, because there's a 4 on the bottom. Remember, the bottom is going to be the index. The top number is going to be the exponent. So this is the fourth root of 16, that whole thing raised to the third. Okay, grab your perfects chart because we can actually do this. So when we look on our perfects chart, the fourth root of 16, is 16 in the fourth column? Yes, so the fourth root of 16 is 2. And then 2 to the third is 8. So ultimately our final answer here is 8. Okay, number 9 is a little bit nicer. What do you notice in number 9 that's different from number 8? The index matches. When the index matches, can I just have my highlighter? Thank you. When the index matches, you can multiply them together. So 25 times 5 is 125. And then check your thirds column. Can we do the third root of 125? The third root of 125 is 5. Feel free to pause the video and try number 10 on your own. Number 10, it is the 6th root of 8 times the 6th root of 8. The index does match. So we do the 6th root of 8 times 8 is 64. 6th root. We haven't gone to the 6th column very often. 64 is in the 6th column. The 6th root of 64 is 2. Number 11. This one's kind of weird because we're kind of going to do a full circle here. Because the index matches, this is the third root of 6 over 48. We can combine those two numbers together under one fraction, underneath that radical. I feel like the fraction 6 over 48 we could simplify. If I do that in my calculator, I get the fraction 1/8. Or you could do 6 divided by 6 is 1, 48 divided by 6 is 8. Now that we've simplified it, I'm going to split it back up again. The reason I'm splitting it back up is that I see both 1 and 8 in my perfects chart, so I know that we can do the cube root of each of those numbers. So then we split it back up into the cube root of 1 over the cube root of 8. The cube root of 1 is 1, the cube root of 8 is 2. And 1/2 is certainly a lot simpler than the cube root of 6 divided by the cube root of 48. Number 12 is another example where the index does not match. We've got a square root of 5 over a fourth root of 5. If the index doesn't match, we're going to switch to rational. So the square root of 5 is 5 to the 1/2. The fourth root of 5 is 5 to the 1/4. We're going to use the properties of our rational exponents to simplify. When we're dividing with the same base, what do we do with those two exponents? We're going to subtract them. 1/2 minus 1/4. You can do 1/2 minus 1/4 in your calculator, or if any of you like to cook, bake, measure things in the kitchen, 1/2 of a cup minus 1/4 of a cup is 1/4 of a cup. So this is 5 to the 1/4. The one kind of annoying thing is that we have to switch this back to radicals. The problem started as a radical, so it needs to end as a radical if we don't have like just a whole number. So 5 to the 1/4 is the same as the fourth root of 5. That next example, number 13, we're skipping. We're going to move on to this. This is write the expression in simplest form. You're definitely going to need your perfects chart for this. So we took things a long time ago like the square root of 60 and split it up into the square root of 4 times the square root of 15 and then simplified it from there to get 2 times the square root of 15. We're going to do the same thing with cube roots, fourth roots, fifth roots. So we've got the third root of 54. If I look in the perfects chart, I don't see 54 on this chart. So I need to split this up into the cube root of something times the cube root of something. This first number needs to be something in the perfects chart so that we can actually do the cube root of that number. So look at numbers that are smaller than 54. The first number that's smaller than 54 is 27. Can we do 54 divided by 27? I think we can. 54 divided by 27 is 2. So 27 times 2 is 54. We split that 54 up into 27 times 2. This one's on the chart, so we can actually calculate it. The third root of 27 is 3. So our final answer is 3 times the cube root of 2. Now, how you write your answer is incredibly important. Most of the time, you're going to be entering your answer into the computer. So you type in 3 and then you look for the button that has like a little field and then another field so that you can type something into the index and something into the radicand. But if you accidentally write this like this, is that 3 times the square root of 2? Is that 33 times the square root of 2? Is that 3 times the third root of 2? So make sure you're very deliberate about tucking that index into the check marky part of the radical. For the fourth root of 64, we're going to be looking in the fourths column at the numbers that are smaller than 64. We want to split this into the fourth root of something on the chart times the fourth root of whatever other number you'd multiply by to end up with 64. So you really want this one to be on the chart. So smaller than 64, we've got 16. It'd be really helpful if 16 worked. 64 divided by 16 is 4. The fourth root of 16 is 2, so we have 2 times the fourth root of 4. Try number 3 on your own. This sounds funny, but don't think too hard. So I know that we need to split this into the third root of something times the third root of something because we're working with third root. When I look in the thirds column at numbers smaller than 10,000, all of them are smaller than 10,000. So when I said don't think too hard, I'm hoping that the number 1,000 stood out to you. 1,000 times 10 is 10,000. The third root of 1,000 is 10, so our answer is 10 times the cube root of 10. So yes, you're looking for numbers smaller than your original number, but also kind of use whatever the number is to your advantage. Do you guys know the tricks about like it's divisible by 9 or it's divisible by 3 if the numbers add up to a multiple of 3 or something like that? No? Oh well. Next up is rationalizing the denominator. The third root of 2/3 is the third root of 2 over the third root of 3. The problem with this is we can't have a radical on the bottom. Do you remember that from square roots? Radicals on the bottom are bad. We need to get rid of the radical on the bottom. So here's what we're going to do. We're going to multiply by a funky version of 1 to end up with the cube root of something that is on the perfects chart. This number needs to be on the chart, because then we can do the third root of that number and end up with a whole number on the bottom. So I'm going to look in the thirds column and think about the number 3. Can I do 3 times something to get 8? Not really. Can I do 3 times something to get 27? I think so. So my goal here is I want to have the cube root of 27 on the bottom because I can do the cube root of 27. So 3 times what gives me 27? 9. We have to multiply the top and the bottom by the cube root of 9. 3 times this number gives us the number that is our goal. Okay, then on the top, the cube root of 2 times the cube root of 9, that's going to give us the cube root of 18. So our answer here is the cube root of 18 over the cube root of 27 is 3. We no longer have a radical on the bottom, so mathematically this answer is now beautiful again. In math, having a radical on the bottom is very ugly, awful, terrible. We have to resolve that so that it's, again, beautiful and fine. We're starting with the fourth root of 8 on the bottom. We want the fourth root of something that's on the chart. 16 would work. That would be multiplying by the fourth root of 2. I've got the fifth root of 4 on the bottom. So I go to my fifths column and I look at the numbers that are bigger than 4. Sometimes it's very easy to spot. I know that I can do 4 times something to give me 32. So that's my goal. 4 times what gives me 32? So 4 times 8 is 32. We multiply the top and the bottom by the fifth root of 8. That's what we use to get to our goal. And that ends up giving us the fifth root of 24 over the fifth root of 32. So our final answer is the fifth root of 24 over the fifth root of 32 is 2.